Novius welcomes you to video demo of Novius MVIS version 2, which is real-time machine vision-based inspection system for railway vehicles. This system includes high-speed machine vision or computer vision cameras.
Railway vehicles, due to their very nature, are prone to mechanical failures. To keep railway vehicles under control, and to limit as much as possible the consequences of accidents arising from failures, it is necessary to consider the possibility, and the need, to check rolling stock conditions from stationary measuring equipment. Many of failure causes could be detected by the use of technology. Machine vision allows to pinpoint potential problems and quickly address them before they grow into larger issues that can cause derailments,
which take very high-speed images of rolling stock to detect any anomaly present. This in turn generates relevant alert to the user for examining the anomaly through images and to take necessary corrective action. Novius MVIS version 2 system has portal poles containing detection sensors, cameras, lasers and lights to function. This system can be used to automate the maintenance of trains through machine-based visual inspection. Further, the high-end software not only ensures that defects are reliably detected but also tries to predict the defects before their occurrence. The system significantly improves the quality and reliability of inspection measures and can greatly reduce railway service downtimes. Traditionally, the real-time railway inspections are done by train technicians by observing and visually inspecting the ongoing trains by human eye. This is very laborious and time-consuming process and also is prone to human errors. This system comes along with axle box temperature measurement system to detect hot axle box and hot wheels. This system is assisted with thermal cameras to get the thermal profile of axle box and wheels. Now we will try to understand various aspects of Novius MVIS through trials done. As a train passes at track speeds up to 35 km/h, the Novius MVIS version 2 system records digital images of the rolling stock. Machine vision algorithms identify the presence and condition of various components and detect anomaly and defects on all rolling stock passing the system. The automated algorithms are currently for wagon only. Other rolling stock types will come later. There are many challenges for machine vision systems. Starting from making system comprehensive to adapt to many different types of trains, at different speeds, many kind of defects and large number of parts to be checked, the wide variation of car types, safety appliance locations, and undercarriage configurations requires very robust recognition algorithms as well as extensive image acquisition. Careful consideration must be paid to camera angles and views. Also, lighting solutions can be very challenging. Varying ambient light and shadows make it difficult to get consistent images of every component in all night and daytime lighting conditions. Inspections include bearing end cap bolts, missing springs, broken springs, friction wedge missing or high, and broken journal bearing adapters. Figure shows example images from the bogie inspection cameras. These images can be used to detect load imbalance, diagnose spring condition, measure wedge rise, count end cap bolts, and find broken bearing adapters. Test systems demonstrate automatic detection of spring condition and bearing end cap bolts.
Vision systems can objectively inspect rolling stock and can also focus on certain parts of the railcar not easily seen by an inspector on the ground. If implemented properly, then system has the potential to drastically reduce the inspection time, up to 1/10 of the total time needed, and also will build the evidential database for the inspection performed. Further, this database can be used for prediction of the impending failures. Hence, this can be built as predictive system rather than just limited to defect detection system. It will surely improve the quality of maintenance, less service downtime, better reliability of rolling stock and hence better throughput of rail network. The ability to image the entire rolling stock opens the possibility for several applications. Lower positioned cameras provide detailed images of bogie, brake rigging and draft pocket components that can be scanned for defects and unusual wear. The potential to increase both the effectiveness and efficiency of rolling stock inspections by utilizing machine vision technologies enhances the rolling stock inspection process and offers an opportunity to improve safety, lower costs, and increase productivity. Machine vision applications hold great promise for the future of the train inspections.
Complete machine vision-based systems are being developed under the guidance of the Indian Railways by Novius Rail Tech, Pune.